All right, you rascally chemistry students. So today, right, you're here probably because you need a little help with some stoichiometry, right? Well, hey, join that crowd. If they did a poll of high school chemistry students, one of the topics most kids say they struggled with is stoichiometry, all right? So what we're going to do here with this tutorial video is we're going to zoom in and pick apart one of the problems from ChemQuest, and that would be question number 5, the very last question on the very back page of that ChemQuest. All right. The reason I chose that one is it's a start to finish problem. You gotta write the molecular equation and you gotta balance it. You gotta convert to moles. And you gotta use your mole ratio to predict how much product we get, etc. All right. So I'm gonna go nice and slow, step by step through this process. Break it down for you guys. So what you guys need to make sure you have in front of you so that you're ready to go. You know, your handy calculator that'll help speed things up. And then of course that periodic table, ever useful periodic table, so that we can do those steps together. And again, remember the idea here is for you guys to hit pause and try to work some of this out yourself, right? It's not entirely interactive in a video, but interactive in that you can pause, rewind, go back and try things yourself, see what you're confused on, etc. All right, so we're gonna get started, and I'm actually gonna start by really kind of annotating this question, all right? So it does say when 53.6 grams of calcium carbonate react with plenty of aluminum fluoride, how many grams of each product can be produced, all right? So you guys will notice here that I didn't give you the formula yet, so we're gonna go back to like the stuff we did last chapter, writing out the actual molecular equation, predicting what our products are, writing the correct formulas and balancing. So there's that whole piece in and of itself that gave some of you guys trouble, okay? But let's annotate a little bit. This is an important number, 53.6 grams of calcium carbonate, right? So the formula for calcium carbonate is, we should know, calcium is going to be a +2, carbonate's a -2, right? We get that information from our periodic table, and the carbonate there would tell me to go to that polyatomic ion sheet, right? So my formula for calcium carbonate is going to be CaCO3. And I don't need to add any extra subscripts there because they're both 2s. So one of each does the job of neutralizing, right? Now, I'm going to react with aluminum fluoride. Is my other reactant, right? And aluminum is +3, fluoride's a -1, right? And we know that again because of the information that handy periodic table uses. So I'm going to add calcium carbonate to AlF3. Okay? So these are 2 reactants, right? So we have to consider, I'm going to write little charges above here just for reference. +2, -2, +3, -1. Okay? Now, because that's going to help me predict my products on the other side. So I'm not going to spend too much time on this because that's the last chapter stuff, right? So if a reaction does occur, that means that calcium and aluminum are going to swap places, right? A plus will always replace a plus, or you can think of it as a minus replacing minus. Doesn't really matter in this case, all right? So my products then, I'm going to put calcium with fluorine, right? So my new formula on this side is going to be CaF2, right? Because it's a 2 and a 1, plus Al2CO3, 3. All right? So that's my skeleton equation, right? Now I'm going to erase those charges just so they don't muddy the waters too much. All right? So we've got that skeleton equation. These are the correct formulas to make neutral compounds, right? And so what I have to do, because my subscripts don't look the same on both sides, I got to go back and use, what's the word? Coefficients to balance this out. All right? So in the case of this particular problem, I've got to look at what's out of balance, right? So I notice right here, I've got 2 fluorines versus 3, right? So whenever I have a 2 on one side and a 3 on the other, that's my automatic indicator to bring them both up to 6, which you should remember from last chapter, right? So if I've got 3 fluorines, I want to make that 6. I'm going to put a coefficient of 2 there because 2 times 3 is 6. all right? Now I've got 2 fluorines here, so I'm going to put a coefficient of 3 to bring that one up to 6, all right? So we'll kind of start there, and then we'll see how that affects us with our other elements and compounds, okay? So 3 calciums there. I'm only showing 1 here, so that means I need to try with 3 right here, okay? Which also means I have 3 carbonates. So hey, would you look at that? I've already got 3 carbonates right here. And you notice when I put a 2 here, that gave me 2 aluminums. And hey, look at that, 2 aluminums there. Okay, so we added in these coefficients, 3, 2, 3, right? And essentially we have a 1 there. We just don't generally write 1s in chemistry or formulas and stuff like that. Okay, hey, so guess what we just did? Those steps I gave you last week, step 1 is write a balanced molecular equation. Bam, step 1 done, right? So now we've got some key information to get us started, right? This is a pretty essential step, all right? So we've got our balanced molecular equation. So now what are we being asked to do? We want to calculate the number of grams of each product. All right, so that tells us we have 2 products. I want to know the derivatives of both of them. I actually have to do 2 stoichiometry problems for this question. One's enough. Now you got to do 2. Huber, what are you doing to me? All right, so how many grams of each product can be produced? All right, so what we have here is a classic stoichiometry problem, in which case we know the amounts of one of our products. The other one says we have plenty of, right? I'm going to kind of that. Plenty of aluminum fluoride. That means I've got enough aluminum fluoride to use up all the calcium carbonate. And we'll do limiting reactants next, which adds even more steps. You guys are going to love that. But that's what that refers to. Like if I didn't have enough aluminum fluoride, I wouldn't be able to use up all of that calcium carbonate. So they just add that sentence in there to indicate that really the only number that matters to us is that calcium carbonate number. Okay? So, step 2 in our stoichiometry problems is, right, to convert our known quantities into moles, right? Because it's that mole value that allows us to have an intermediate to compare different elements, different compounds, right? Because they all have different masses, but if we put them into moles, then we have that interchangeable unit. It's beautiful. That's the beauty of moles, all right? So, step 2, we're going to convert our known quantity into moles. So what quantity am I given in the question, right? It's my grams of calcium carbonate, this number right here, 53.6 grams of calcium carbonate. So I'm going to convert that into moles, all right? So I'm going to take my 53.6 grams of calcium carbonate, all right? Now, you guys should have, at this point in your career, you should know how to convert grams to moles. You should know how to do that. You divide the mass you're given by the molar mass of the material. The mass divided by molar mass, okay? So what I need to know then is the actual mass of calcium carbonate, okay? And so what I do, of course, is I take my mass of calcium plus the mass of 1 carbon plus the mass of 3 oxygens. Now notice I'm not worried about this coefficient of 3 here for my mass. It's because we're going to deal with that 3 in a minute, all right? So all we're doing is taking calcium carbonate, this formula right there, CaCO3, calculating this molar mass, and then dividing by that to get our moles, okay? So step 2, convert known quantity to moles. And so when I add 1 calcium plus 1 carbon plus 3 oxygens, I should get, with our periodic tables, 100.09 grams of calcium carbonate, 1 mole of calcium carbonate. All right? Now, I've shown you guys in class how to continue that out, right? To calculate grams of this or grams of that, but I'm actually going to do this and just get this to moles. So what that's going to do is, because I have to do 2 stoichiometry problems, I'm going to do this once and get the answer, and that way I can use that same number in the rest of the work. I don't have to do this step twice, essentially. Okay? You could, if you want, you just tack this onto the rest of it. But I find it easier often just to get the one number I do know into moles and then use that mole number for the rest of the problems. Okay? So when I do this calculation, right, 53.6 times 1 divided by 100.09, I should get, rounding to 3 sig figs, 0.536 moles calcium carbonate. Okay, I'm actually not going to highlight that because that's not our answer, right? That is just the number I'm going to use, right? So now, step 3, right, and the steps I gave you is to multiply it by the mole ratio, okay? And I think based on the conversations I've had in class with lots of you guys, it's this mole ratio step. It's actually the easiest step, but I think it's the one that gets people most confused because you're not sure where to put numbers, right? So what we want to do with this particular problem is, okay, we have our moles of calcium carbonate. We want to figure out how much we get of our products, right? So we just pick one of the products because we're going to do both of them anyways. Pick which one we want to start with, all right? So let's say since I have calcium fluoride written first, I'll start with that one, all right? So here's what I'm going to do. I have 0.536 moles of calcium carbonate. Okay, 0.536 moles of calcium carbonate. And I want to figure out how much calcium fluoride I should get. Okay, so what I'm going to do is I'm going to compare the coefficients for these two, right? This is the quantity I know, so this is the coefficient on the product side I'm concerned with. Well, how much calcium fluoride will I get from that much calcium carbonate? All right, so again, I've got plenty of aluminum fluoride, so that's not a number that's going to limit how much I get on this side. It's the number I'm getting here, okay? So in this case, it's a 3-to-3 ratio, right? But just for the sake of logic here, it's 3 moles calcium carbonate convert to 3 moles of calcium fluoride. Okay? Now, again, how would I know which to put on top in this case? What you use, the logic you use is whatever you're trying to convert to goes on top. So whatever you're converting to goes on top. Say it with me. What you convert to goes on top. All right? Now, in this case, they're both 3, so we kind of just have a straight up cancellation there, right? Okay? But what that does is converts us from moles of calcium carbonate to moles of calcium fluoride. All right? Now, I'm actually not going to put my equal sign there yet. The next thing I need to do, right? Because in the question, it doesn't ask how many moles of each product do I get. It asks how many grams. But no problem. We know how to convert moles to grams. Okay? You know that. You know that. So I'm just going to add one step, right? So I'm in moles of calcium fluoride. So in 1 mole, CaF2, that should not be crossed out there. Error on my part. Okay? I have in moles of calcium fluoride, right? So in 1 mole of calcium fluoride, how many grams do I have, right? So again, that's going to be 1 calcium plus 2 fluorides, and the number I should get there, which I've already calculated, is 78.08 grams CaF2. And that equals, when I do it, my calculation should come out to 41.9 grams CaF2. All right? So in that question, it wants to know how many we get of each product, not just calcium fluoride. So that's half the problem done. The other half would then be to figure out how much aluminum carbonate I get. Okay? So next step. All right, so we got that 41.9 grams of CaF2. I'm out of space on the board. I'm going to erase that. So if you need to copy it, copy it. All right, so I'm leaving this up here because I need this number again for the next part of the problem, which would be for the aluminum carbonate. Again, so the next step here, I'm going to take 0.536 moles calcium carbonate. right? And I need to multiply by the mole ratio, right? So this time, I'm comparing calcium carbonate to aluminum carbonate. Now notice this time I have a 3-to-1 ratio. So in this ratio, which one goes on top? Whatever we're converting to goes on top. So we'll convert 2 goes on top. So it's 1 mole on top. Aluminum carbonate to 3 moles calcium carbonate. All right. And again, just like last time, we don't want to know how many moles of aluminum carbonate we have. We want to know how many grams that is. So we just tack on that step. And 1 mole of aluminum carbonate. All right. I need to figure out its molar mass. Now, I've got 2 aluminums, 3 carbons, 9 oxygens. So this number is actually going to end up being kind of big. And when I do that, I get 233.99 grams of aluminum carbonate. Boom, boom, boom. And my final calculation, I should get 41.8 grams of aluminum carbonate. Done. So again, quick review of those steps. First, right, we have to write out our correct structural formula, molecular formula that's balanced, right? Then whatever number I'm given, right, needs to be converted into moles. So I did that step here because I knew I was going to have to use that number more than once, right? Then, once I know how many moles I have, I'm going to take the number of moles I have times the ratio of whatever I have to whatever I'm trying to find. Okay, so in the case of this problem right here, I compared a number I knew for calcium carbonate, and my ratio was 3-to-1, right? But what am I trying to convert to? Aluminum carbonate, so the 1 goes on top as opposed to the 3. That's this step, right? Then, because I want my answer in grams, and in moles at this point, I need to multiply by the molar mass to get the number of grams, all right? And that's stoichiometry.